the eternal fireworks of T Coronii Borealis, a nova you'll see with your own eyes in 2024. Have you ever heard of a star that explodes every 80 years, only to survive and do it again? We're not talking about science fiction or myth. This is a real cosmic phenomenon, and it's about to grace our skies in a once-in-a-lifetime visual spectacle. In September 2024, we will witness one of the most anticipated astronomical events of the decade. A nova in the star system T Coronii Borealis, a powerful thermonuclear explosion that won't destroy the star, but will make it appear like a brand new star in the night sky. You won't need a telescope. You won't need to live in a remote mountain village. If you can see the stars from where you are, you'll be able to witness this amazing moment in the story of the cosmos. Fire nova versus supernova, a tale of two explosions. When people hear stellar explosion, their minds often jump straight to the word supernova, those cataclysmic events that mark the death of massive stars, sometimes leaving behind neutron stars or black holes, and sometimes obliterating the star entirely. Supernovae are so energetic they can briefly outshine entire galaxies. But what we're about to witness isn't a supernova. It's a nova, which is no less spectacular, even if it's less destructive. In a nova, the star isn't destroyed. Instead, it's more like a recurrent outburst of incredible energy from a white dwarf, a dense, Earth-sized remnant of a once sun-like star. In a binary system, this white dwarf steals material, primarily hydrogen, from a companion red giant star. Over time, this hydrogen builds up on the white dwarf surface until it ignites in a thermonuclear explosion. The star suddenly becomes thousands of times brighter, visible to us as a brilliant new light in the sky. Then it fades. The white dwarf survives, and the cycle begins again. Milky Way meet the star of the show, T Coronii Borealis. This upcoming nova will occur in the star system T Coronii Borealis, located about 3,000 light-years from Earth, nestled in the constellation Corona Borealis, also known as the Northern Crown. T Coronii Borealis, often affectionately called the Blaze Star, is what astronomers call a recurrent nova, a rare type of system that erupts not once in a millennium, but repeatedly over time. It was first observed to flare up in 1866, creating what many thought was a new star. Then again, exactly 80 years later, it exploded in 1946, and astronomers began to understand the rhythmic nature of this star's outbursts. Now 80 years after that second documented event, all signs point toward another eruption in 2024. And this time, we are ready. Telescope how and where to watch the nova. The best part? You'll be able to see this with your naked eye. Here's how to find it. Look toward the constellation Corona Borealis, a beautiful arc of stars located in the northern sky, between the constellations Boötes and Hercules. The arc looks like a semicircle or a celestial crown. The brightest star in the arc is Alphecca, also known as Gemma, and once you find it, you found the heart of Corona Borealis. The nova will appear within this arc, as if a new star has suddenly materialized out of nowhere. During its peak, it is expected to shine with a magnitude of 2.5 or brighter than Polaris, the North Star, and comparable to Vega or Arcturus, two of the brightest stars in our night sky. Even in cities with light pollution, the nova should be clearly visible. It will be one of the few cosmic events that brings space to everyone, no telescope required. The best time to view will be late evening, when the constellation is high in the sky. Collision, what happens during a nova? Let's take a journey into the heart of the white dwarf. White dwarfs are the final evolutionary stage of sun-like stars. When such a star exhausts its hydrogen, it sheds its outer layers and leaves behind a core made mostly of carbon and oxygen, compacted into a dense sphere about the size of Earth. In T Coronii Borealis, the white dwarf's red giant companion is bloated, cool, and losing mass. This outer gas is drawn to the white dwarf, pulled in by its immense gravity. This gas doesn't fall directly onto the star. Instead, it forms an accretion disk, slowly spiraling inwards. As the hydrogen builds up on the surface, it compresses under gravity, and the temperature rises to millions of degrees. When it reaches a critical point, A thermonuclear explosion erupts across the surface in a flash, equivalent to 476 trillion hydrogen bombs detonating at once. This explosion flings the accumulated outer layer into space and increases the star's brightness by over 1,000 times, all in less than a second. That's the nova. And just as quickly, the star begins to fade. The outer shell disperses, the accretion resumes, and the clock resets for another round in 80 years or so. DNA. Why scientists are excited. Beyond the thrill of watching a star light up, this event is a scientific goldmine. Astronomers have been closely monitoring T. Coronii Borealis for decades. Since 2015, they've detected unusual behavior, dips and rises in brightness, bursts of X-ray and radio emissions, patterns eerily similar to those recorded before the 1946 eruption. In 2018 and 2023, the fluctuations became even more pronounced, causing anticipation to mount. Satellites like NASA's Swift and ground-based observatories across the world are currently tracking every nuance of this system. They're measuring the temperature, the composition of the surrounding gases, the rate of matter accumulation, all to better understand the physics of binary stars, accretion disks, and thermonuclear dynamics. Compass novae throughout history. The nova we're about to see is part of a long cosmic tradition. In 127 AD, medieval records by the German abbot Burchard von Erzberg mention a mysterious brightening in the same region of the sky, likely an earlier eruption of T. Coronii Borealis. In 1866, the nova was so bright it was visible from urban centers, even without dark skies. In 1946, scientists had better tools and recorded it more thoroughly, cementing our understanding of recurrent novae. This event connects us not only with the stars, but with human history, with all the generations that have looked skyward in awe and recorded what they saw. Crystal ball, what does the future hold? This won't be T. Coronii Borealis' final act. After this explosion, the white dwarf will likely continue the cycle for thousands, or even millions of years. Eventually, it may accumulate so much mass that it surpasses the Chandrasekhar limit, about 1.4 times the mass of our Sun. When that happens, it can no longer remain stable. It will collapse and explode as a Type Ia supernova, an event so bright it could be visible during the day from Earth. But for now, the white dwarf will survive. And so we wait and watch. Sparkle's other novae to watch for. T. Coronii Borealis isn't the only recurrent nova in the galaxy. Rs Ophiuchi, another white dwarf red giant pair, with eruptions every 20 years. The last eruption was in 2006, and we're due for another in 2026. Scorpii. With a much shorter cycle of about 10 years, this system erupts frequently, but lies 47,600 light-years away, making it visible only through telescopes. These systems are rare windows into extreme astrophysical processes and future light shows waiting to happen. Shooting star, don't miss the show of a lifetime. For the lucky among us, this will be the first and only time we see T. Coronii Borealis go nova. It's an event that combines beauty, science, and rarity in one incredible package. A true cosmic spectacle that reminds us how alive and dynamic the universe really is. Set a reminder. Mark your calendars. And when the sky darkens in September 2024, look up toward the northern crown. You'll see a star ignite in real time, a thermonuclear heartbeat from a system 3,000 light-years away, pulsing through history and landing for a short time, right into your eyes.